In this video, we're going to talk about something called composition of functions. This is going to be a fifth operation, a fifth thing that we can do when we have two functions here. Previously, we've done adding, subtracting, multiplying, and dividing functions, and they were fairly straightforward. We would just go ahead and add up the formulas for them or subtract or whatever it may be. But this next one that we're going to see is going to be significantly harder to deal with. It's something called composition of functions. So let's go ahead and see it here. So we're going to write it down using this notation. And sometimes we'll call that fog. And if you have it the G first, we're going to call it goff. It doesn't really matter how you pronounce it, but that's something that is done kind of pretty normally here. Now what it means is, it doesn't mean you're adding the function, it doesn't mean subtracting, anything like that. It means that you are taking one of the functions and you are replacing it in for x in the other function. Okay, so the idea is you have a function and you plug that, you replace that value in for the x in the other function, and you're going to get what's called a composition of functions. Okay, so let's look at an example here. It says f of x is x squared plus 2x plus 3, and g of x is 5x minus 1. And we're trying to find f composed with g of 1. So that means that we're going to go ahead and plug 1 first into the g function, and then after we plug it into the g function, we are going to go ahead and get that result and plug it into the f function. So what do we see here? We say, okay, well, this is supposed to be plug 1 into g, get an answer, and then plug that answer into f. So what happens if I plug 1 into g here? It'd be 5 times 1 minus 1 is going to be 4. And then we're going to take that number and we're going to plug that number into the other function, to f. And so I'd have 4 squared plus 2 times 4 plus 3. And we're going to get 16 plus 8 is 24 plus 3 is 27. And so that would be the value we get out here. So we are going ahead and taking the number 1. We're first plugging it into the g, which is the one right next to it. We are then getting an output of that. Then we are taking that output and we are plugging that into the input of the next function. And that gives us the overall output of the composition. Okay. Now, what if you don't have a specific value of x? What if instead you are just trying to find a formula that will work for any value of x? Well, that is the same idea, that you're going to take the g and you're going to plug it into the f here. And so what is my g function here? My g function is 5x minus 1. And I'm going to then plug that into the f function. So wherever we see an x over there, we're going to replace it with 5x minus 1. 2 times 5x minus 1 plus 3. Okay, so then if we square the 5x minus 1, we would get 25x squared minus 10x plus 1. Then we would distribute the 2 in, 10x minus 2, then plus 3 here. And then at this point in time, we're going to go ahead and combine like terms. And let's see, we get 25x squared, let me rewrite that there. 25x squared minus 10x plus 10x cancels, and 1 plus 3 minus 2 is plus 2, and the final function would be 25x squared plus 2. Okay, so this is what we have here. Now I do want to show you something in this next example, that if we go ahead and replace the ordering here, instead of being F circle G being G circle F, then we're going to get a different answer to this problem here. So this would mean you take your f of x function and you plug that into the g of x function. So that means we're plugging our x squared plus 2x plus 3 function in to the g. And let's see here. So the g function says 5x minus 1, so 5 times that whole thing minus 1. And what are we going to get here? We are going to get 5x squared plus 10x plus 15 minus 1 is plus 14. And you can see how we get a very different answer this time than we did previously. And again, this is important that when you are doing composition of functions, it matters very much which order you put things in. You always plug things into the right function first and then into the left function. That's how the ordering works. Now, there's one more thing that we can also do with these problems is that we can not only find the composition, we can go ahead and look at the domain of the composition and what it's going to be. And so we can figure this out here as f circle g, so f of g of x. And let's see here. We got, so g of x is 4 over x minus 1. And then we're going to go ahead and plug that in the fx, which is 1 over this thing plus 2. Then we need to go ahead and simplify this. I'll multiply top and bottom by the LCD x minus 1. And then we're going to get x minus 1 over 4 plus 2 times x minus 1 is x minus 1 over, let's see, 2x plus 4 minus 2 is going to be plus 2. And this would be your simplified version of your f circle g. Now, if I want you to find the domain of this, normally what you would do is you would go say, okay, domain, I look at my fraction 2x plus 2, or the denominator 2x plus 2, set it equal to 0, and this gives me the one value of x I'm not allowed to have. It can't be negative 1. However, if you tell me that's the domain, you're actually incorrect. The reason why is this is not just the final function. This is a composition of functions. That means we took one thing and plugged it in another thing. And so that means whatever x you have first has to get plugged into g, and then the answer has to get plugged into f. And so if you look up here what g was, what would happen if you tried to plug in, let's say, 1 into that? It'd be undefined, and if your first step breaks, it's undefined, you can't possibly have the second step anyways. So even though you could plug in 1 here and get an answer, it would actually be meaningless. So what you have to do on these problems is not only look at the domain from the final expression, but you need to also worry about whatever comes first in your composition. In this case, x can't be 1, and you need to combine both of those restrictions in order to get the final domain. So the domain here should be x is not 1 or negative 1.